Hi. Exam 3 review. I know. Yes. So, this is tomorrow. And we're talking about chapters 10 and 11. We have 3 topics to worry about. Sequences, which is order list of numbers. Series, which is sum of the sequence. And power series, which is chapter 11, which in some sense power series are like, functions on series. We standard about 10 problems, or 8, we said. I think we said 8. Yeah, we said 8. 8 problems. And it's supposed to be an hour long. So 1 hour, 8 problems. Good thing I remembered. Now, you have those 10 tests for series. That's the paper I gave you. You have 1 test for sequences. It's the limit test. And for power series, you have few skills. Obtaining power series. We are looking at the Taylor Taylor expansion. We have interval and radius of convergence. That was a ratio test. Could be root test as well, but ratio test. And 3, calculus with power series. That's the whole exam. Now, in blood, skill. It's very important. Number 1, check each series problem with limit an different than 0, because that's a divergence test. Number 2, never use anything else but tests from the sheet. Please don't try to make up stuff. Now it doesn't work. 3, alternating series have 2 types of convergence. Absolute convergence, conditional convergence. So don't just say, oh, converges and move on. Which one? You want the full credit, right? Which one? Is it absolute or conditional. What else is important? Limit and direct comparison tests are the last resort tests. Don't push to do those first. Go through the whole list. You already checked number one, check the series for that one, for divergence, and if the limit is 0, then you get to look at the other ones. Is it in a form of geometric? Can I use partial fraction decomposition for telescoping if it's not telescoping already? Is it P series? Is it alternating series, -1 to the n? The ones that you want to check at the end obviously are integral test, because that one takes forever, right? You have to do the 3 conditions for integral test. For integral test, show that 3 conditions hold, then integrate integral and sum share the same fate. Let's just say both converge or diverge. In case of convergence, integral and sum converge to different values. So please do not say, oh, integral was, let's say, convergent at 7, and then you say series converges at 7. No, we don't know where it converges to. 6. Memorize the sum formula. S equals A over 1 minus R for geometric series, obviously. What else? Geometric series start at 0. Anything else, we must shift the counter. If you don't know what I'm talking about, the lecture has details on shifting the counter. Straightforward, it's just a procedure that takes some time. Eight. Ratio test is your friend. That means that if you are stuck on a problem, it doesn't look like geometric series, it's close. At the same time, it's a P series, right? It's easy. If you have a factorial, you know it's a ratio test. But, so, summation of 4 over n plus 1 factorial, that's ratio. Summation of 4 to the n over n plus 3 to the 10, that's also ratio. It's also ratio. No factorials in this problem, but you have exponential on top and a polynomial on the bottom. This one is supposed to be geometric. This one is supposed to be P series. So which one wins, right? Well, neither. because you can't do two separate tests in the same problem. So ratio is your friend in that case. Through the experience, this one converge, this one diverge. You can go and check those problems when you practice. I gave you the answer now. Make it work. Both are ratio tests, so it should be easy. What else? Power series, 4 terms. What else? Is there anything else? So divergence, telescoping, geometric integral test, 2 comparison root ratio, alternating and P series. I think that's it. Integral test has the improper integral, so be careful. Well, you'll see the infinity, right, once you do the integral test. Remainder is the next term. Now, the first term that you're dropping is the remainder, right? Carries most of the error. Is there anything else? We can center around any value by writing x minus a to the right for power series. Center about x equals a. We're going to have a power series summation 0 to infinity Cn x minus a to the n. So that's where the a would come in. And obviously a is in each one of the derivatives you took. So that's the list. Power series. 4 terms for f of x equals, let's go find a problem, because generally that's where you do terrible. Taylor series for ln x at a equals 3. Go. So 4 terms, you need 3 derivatives, right? Okay, let's take a look at it together. So the power series f of x is going to be summation Cn x minus a to the n from 0 to infinity. The first term is just f of a because that's a zero derivative, plus hold on, I meant to say C0 C1 x minus a plus C2 x minus a squared plus C3 x minus a cubed plus dot dot dot. Those dots are there because it goes to infinity, and that's why you are allowed to put equal sign. Now, for f of x to be approximated by the power series, we're only going to use the first four terms, sorry. So we have these guys. No dot 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 this time because we are using exactly four terms and that's it. Now, coefficients, Cn's. So this is the formula. And now formula for Cn is the nth derivative computed at a divided by n factorial. So that's a formula as well. So the function f of x is given as ln x. The first derivative is 1 over x. The second derivative is negative 1 over x squared. And the third derivative is positive 2 over x cubed. Those are my derivatives. They need to be calculated, as you can see, at a, and I have that a is equal to 3. So all of those at a equals 3. Well, we'll get there. So C0 is f of a, which is ln of 3. C1 is f prime at a, which is 1/3. C2 is f double prime at a, which is negative 1/9. And C3 is the third derivative computed at a, which is 2 over 27. So now, ln of x is approximated by ln 3 plus 1/3. Remember, it's divided by n factorial. I didn't do that yet, but this is divided by 1 factorial times x minus a is 3. Plus, well, minus 1 over 9 divided by 2 factorial x minus 3 squared plus 2 over 27 divided by 3 factorial x minus 3 cubed. All I need to do is to clean this algebra a little bit and I will have my polynomial to work with. So ln x is approximately ln 3 plus x minus 3 over 3 minus 2 factorial is 2, so 1 over 18, so x minus 3 squared over 18 plus 3 factorial is 27, so that's 27 squared, whatever that is, 2 times x minus 3 cubed. So now you can go and expand if you want and so on, but this is technically the answer without, computing and expanding everything. You don't have to, but You can square this and cube that, and then find the common denominators, put all x cubes together, x squares, x's, and constants. It's just too much work for no payout because we have computers today. So over here, this thing is called 4-term approximation of ln x at a equals 3. You change a different value from 3 to something else, obviously the entire thing changes. And we said that we want to center it at some number because we want to have good approximation for the numbers. Now we can test this on Desmos. Let's say you care, you want to practice at home, right, to see if your calculations made sense. You have ln x, which is a function, and now you type in all of the rest. ln 3 plus open parenthesis x minus 3 divided by 3, and then minus open parenthesis x minus 3 squared divided by 18, and without even typing the next term, we see that I put the mouse cursor here where 3 is. You see that these guys are perfectly aligned at 3, and they are together on top of each other, providing same or very close y values for some time. Now, I'm going to add one more term, and then this black line is going to open a little bit more and follow the purple for a little bit longer. The more terms you have, the further out it goes to match the whole thing. So now I'm going to add plus 2 times x minus 3 cubed divided by 27 squared, and as you can see, that bent the function a little bit more. You know what? I'm going to actually copy this part into a separate line over here. So now you see that the black line is a little bit closer and a little bit better than the red line as you go to purple line. Purple line is the ln. So you see that the purple line is ln, and you see that the black line is always closer to purple line, right? Black line is always closer because black line has more terms than the red line. Now red line is not bad because we centered at 3, because maybe we had integral that went from 2 to 4, right? We had integral that went to 2 to 4. That's good. If you look at that picture, right, integral 2 to 4 with the ln centered at 3, here's where the 2 is, here's where the 4, that's a 3, right? So you can pretty much see that red and black and purple, they're all in the pile. Are they the same line? No, they're not the same line, but they are very close. So usually that's where most of the issues are for you guys, and the rest is, you know, pretty straightforward. I would think. I don't know. You have everything?
Yes.
So you're fine.
Yes, thank you.
So that's it for today. We have the exam tomorrow. After the exam, we have one more section, and then we're done. What's the target grade? Oh, it doesn't matter because you took the